You should recognise this rock, paper, scissors application that we started in the previous videos. Now, we have so far got it where we can choose the round, so say if I did 2 rounds, you can then enter rock, paper or scissors by entering the letters, and then it says whether the computer wins or the player wins. And then I could choose another option, and then we have totaling the scores. Here's the grand total. The user score is 0, computer score is 1. So we know that that's worked well because this worked out as a draw, so actually the computer wins after 2 rounds. So we have got this code that we've got here. Now, one thing that's really important when you are coding something is that you do something that is called data validation. Now, data validation is basically where you look at the information that is being entered, and if it's not valid, then that information is rejected and your system will repeat and keep going through until a valid response is entered. So if I, for example, had this one here where it says how many rounds would you like to play, if I just put random things in like this and then hit enter, currently it actually crashes the program, so it just stops and ends. Now in our case it's not a big deal because we can just start and restart it, and we know that we can just enter some new information there. However, if you've created a very large system software that you need to run constantly and it needs to be running all the time, you must have data validation because you don't want your program just to stop working, meaning that someone then has to go back through and start resetting it all. The other thing is you don't want to get partway through your program and then the information that's been put in is invalid. So right at the start here, it's important that someone enters a number here, but they could write it just as text, for example, and then it would just crash your system. So what we want to do is we want to have a new function. Now, to create this new function, we can have, so let's say user equals input brackets and here. So let's say, what is your name? So this one we're okay with it being a string, so that's fine. But what we would like is we want our function to have user age. Now the user age we want to be saved as an int, so whatever they enter in here is going to be saved as a number, not as a string. Now the reason you want that is so that you can actually complete some comparisons with it, maybe in your program, so you could see who's older. And as we know from strings, you can't compare a string. So it's really important that you store the information in a certain type, so we're saving it as an int, so a number. And we also want to make sure that the computer is going to accept that. Okay, so if I then did print user, and then I also did print user age, let's say. So what is your name? Just choose a random name. Then I just put something random in here. You can see that it crashes the program. Now what we're going to do is we're going to put another piece of code in here that basically, if it is not valid, or there is something not valid about it, it then means that it is going to keep looping. So we're going to do something called while true. Now, if you type true with a lowercase t, it won't work. So you have to do a capital T, like so, and you'll notice that it changes colour because it is a function. So it is doing a function within Python, so it has a job. So basically what it's saying is while true, it's going to repeat and loop. So this works very similar to our for in range that we were using in our other coding. So here we've got this here, which is another type of loop. So that's why we have the colon at the end, and we have a colon at the end here, and a tab across. So while this statement is true, it's going to keep doing this. We're also going to add something called try. Now what this is this is basically another function. Now basically what this means is try to do something, and if something wrong happens, then do this instead, so accept. So basically what it's going to do is it's going to try this. If something goes wrong with this, it's going to do this instead of that. So I'm going to put a print here to say there was an error. Okay, so that would say there is an error. So if I did run and I put, let's do John again, and then I put something random in here, you can see that it's gone through. It said there was an error, and it says what is your age, and it will keep looping doing this. Okay, but now if I put a valid age in, so say if someone put 18, it's just constantly asking for the age again. It doesn't ever accept any response. Now the reason it doesn't accept any response is because a while true loop will last forever and ever until you tell it to stop. So what we do at the end of this one is we type break. Now what that means is if it does this function, and it will go use age, and if this is valid, it will then break out the loop. So what break basically means is it's going to move to the left, and Python will start reading to the left. So it breaks out of this loop, and then it will go back to print user age with the username as well. So let's try that. So let's do John, and let's say John is 20. Okay, so you can see that it's done John and it's done 20. So using that new information, we can now go to our code here, and we want it to be within this section. So while true, so let's put that into here. So while this is true, we want it to go through the rounds, and we want to use that try function. So try, just tab that across to try the rounds, except, so if there is an error, you want it to print something. You might want it to print, please make sure I have entered a number, like so. You might even say to them, for example, 3, like so. So then if they get it wrong, it will then ask them to make sure they have entered a number, and you've given them an example of how to enter it. So we now need to make sure we have a break here as well, because we need to make sure that it doesn't loop forever. So let's see if that is right, see if we're happy with that. So if we put something random in there, okay, and the really important thing about this is people will use your program, and it's very rare that someone will use your program in a genuine way and try and break it. It's quite rare for that to happen. Normally someone will accidentally do something, or it could be that someone's typing something. So say someone's typed 14, oh, make sure I'm over here on the right. So they've typed 14 and then they've accidentally pressed something else. Okay, it then means that this is no longer accepted. So it avoids any accidents, and that's normally what happens where someone has accidentally entered something. So it's called defensive design. So we use data validation to create defensive design, which means that our system is much more protected, which means that we can make sure that someone is entering the correct information for us. Now, we can't use that same thing with this as such, because we're using strings this time. So what we want to do is we actually want to use our string so that we can make sure that the user has entered rock, paper or scissors, so R, P or S. So what we can do is we can do a while true here. So we're still going to use our while trues, but this time we're going to use while true to check to see if something is equal to a certain value. So what we can do is we can say that if that is equal to something, so let's say, I'm just adding a few lines so you can clearly see what I type. Let's say user input, so just move that there. So let's say user input is equal to Okay, so we want it to be equal to, and we need our if at the start. So if we said if user input is equal to R, then it's going to do something. Okay, so if user input is equal to R, and then we can use OR, and then it's good to practice just to put them inside brackets, just kind of so that you can see where the information is, so it keeps it together. Okay, like so. Or user input is equal to S. Okay, then what you want us to do is we could quite simply just do break here. Okay, so what that will do is it will break out of this while true. So let's have a look. So while true, so just tab that across, tab this one across, and tab this one across. Because what will happen is we want this to read to the right, and then it will break out to return to the rest of our function. So how many rounds? Let's say 2. Please enter a valid response. Let's do an invalid one. Okay, so it's just looping because you haven't entered a valid response. Okay, and even if I included, let's say I included, let's say, it still doesn't accept it as a valid response. But if I do R, you can see that R was chosen by player and S chosen by computer, so that works. We did S, and because we've got 2 rounds, we can see that it's ended and it's got our final score. So by doing that, it protects the system, protects your program, and the reason we didn't need to have a accept there, you can add try and accept there if you really wanted to, but with this kind of function, we don't want that. We just want it to break. We could put an invalid response here, like so, which gives some feedback to the user, which then means I could do, let's say, 2 rounds. Let's say 2 rounds again on the right, and then if I put an invalid one, okay. So we just want to make sure that it's going to print this each time. Now it's not going to work if we put it there, because you've got that as a valid response. So you would have to have another statement to say else, and then do something along the lines of print invalid response, let's say. So that means that we could say, let's say, okay, so what it's done is it's looked at this statement, it's gone, if this is equal to R, P or S, then it's going to break and move on. If it's not, so anything else, is in an invalid response. So like so. So that's how you can get around and have some of these defensive designs as part of your program. So what I suggest you do now is go back to your program, have a look at making sure that your program is safe and only accepts valid responses. You don't want people to be able to enter things that aren't valid, because that will break the program and just leads to a bad user experience.